Okay, so let us begin then. Our class will continue with our class. Yesterday we had talked about the CA code and P code. We had talked about how the ranging is done using the CA code. डिटेल में हमने बात करी थी, कुछ एनिमेशन देखे थे. Basically the time is obtained by the phase difference between the generated signal and the received signal. ये ट्रांसमिशन हुई, यहाँ से जनरेट हुई रिसीवर में, ये चल रहा है आगे. जब ये पहुंचा तो इतना दूर का टाइम जो निकला बिटवीन जनरेशन एंड रिसेप्शन ऑफ द कोड, this time difference is the time that we talk about, is the flight time of the wave, time taken by the wave or signal to reach from satellite to the receiver. That multiplied by speed of light gives us the range. CA कोड के बारे में हमने काफी डिटेल में बात करी. ट्रांसमिटेड ऑन L1 फेज मॉड्यूलेशन से सुपर इम्पोज करते हैं. बाइनरी कोड्स in 0 and 1 form. These 0 and 1s are called chips. The transmission speed we talked about 1.023 Mbps. We then talked about the chip length in terms of time and distance, which was 1 microsecond for a chip, and the distance traveled by the chip was 293 meters. So this was what we did. Now you can just go through the studies, through the notes, and you will be more comfortable with it. So two of the pseudo random codes we already studied. The third component of the data transmitted was navigation message. On the outset, we must understand this navigation message is something from which the receiver finds out the location of the satellite. The satellite actually is not transmitting its position, क्योंकि वो पोजीशन अगर ट्रांसमिट करेगा, जब तक सिग्नल आई प्रोसेस हुआ तब तक तो वो कहीं और होगा. सो व्हाट इज ट्रांसमिटेड इज ऑर्बिटल इंफॉर्मेशन. मैंने बता दिया आपको कि मैं 60 किलोमीटर के स्पीड पे मेरठ की तरफ जा रहा हूं. आई विल बी मेंटेनिंग 60 किलोमीटर स्पीड. मेरठ की तरफ जा रहा हूं, तो आप घड़ी देख के बता सकते हैं कि हाँ अब कहाँ पहुंचे होंगे, अब कहाँ पहुंचे होंगे, अब कहाँ पे होंगे. इफ यू नो द स्पीड, इफ यू नो द डायरेक्शन, then you can find out where I am right now. Using that principle only, the GPS receiver calculates the location of the satellite in the runtime. जैसे अभी अभी अभी, और हर पोजीशन के साथ वो फिक्स लेकर के पोजीशन निकाल के हो रहा है. सर गुड मॉर्निंग.
गुड मॉर्निंग सर. आप इधर हो, मैं उधर हूँ.
आप सर आप भी यही हो, मैं भी यही हूँ सर.
नहीं, मेरा मतलब मेरी क्लास से फेज 2 में हो ना आप?
हाँ, मैं फेज 2 में हूँ.
अच्छा, गुड मॉर्निंग सर. तो ये क्या कहते हैं, मेरी क्लास है आपकी क्लास है अभी?
आई थिंक मेरी क्लास है सर.
सर मैं जरा एक मिनट देख लूँ. हाँ,
I am supposed to be having this class, and this gentleman will be going for testing of the exam, online exam की टेस्टिंग के लिए. तो I will be leaving them at 11 o'clock as per instructions from sir.
ये इंस्ट्रक्शंस तो मुझे दिए थे.
नहीं, वो तो कॉमन आया होगा, ARI कॉलेज में आया होगा.
आज क्या थर्सडे है ना?
यस सर.
ओके, हाँ सर, आप ही का है. मैं फेज 1 में गया, फेज वालों ने बोला सर आपका नहीं है. फिर मैं फेज 2 में आया और यहाँ आप है. चलो इसी बहाने मुलाकात हो गई है. लुकिंग हैंडसम विद दैट दाढ़ी.
तो बढ़िया है ना. आराम कीजिए ना सर. वहाँ जाना नहीं, यहाँ जाना नहीं. आराम कीजिए.
चलिए, ओके ओके ओके, बाय.
Okay, bye bye sir, bye bye. Thank you. All right, so navigation message. We'll go to the board to understand the structure of this navigation message. एक चीज जो समझने की है, that this is a very slow rate transmission, not in Mbps, not in even kbps. It is just 50 bps. एक सेकंड में 50 बिट्स ट्रांसमिट होते हैं. तो हम थोड़ा सा स्ट्रक्चर समझेंगे इसका, कि उसकी स्ट्रक्चर समझ लेने के बाद हम जो लिख रहे हैं आंसर में, वो समझ में आएगा कि व्हाट वी आर राइटिंग. इट विल नॉट बी लाइक ब्लैंक, कि कुछ याद किया वो लिख रहे हैं बट डोंट नो व्हाट वी आर राइटिंग. सो दैट इज व्हाई लिटिल बिट ऑफ स्ट्रेस कि एक्सप्लेन करने में आई एम टेकिंग लिटिल बिट मोर एफर्ट एंड asking you also to put in this effort so that we understand what we talk about. Going to the board for navigation message. Just allow me to set up the camera. Board visible?
Yes, sir.
Okay. So we are talking about navigation message. This navigation message, which is transmitted on L1 and L2 both, again by phase modulation. But this is a slow rate transmission, digital again, binary. Binary code in the form of 0 and 1. Whenever we say digital code, binary code, there has to be speed. So this is transmitted at the rate of 50 bps, no kb or mb or gb. Only 50 bits, only 50, 0 and 1 is transmitted every second. But at this rate, this navigation message is transmitted in the form of frames of 30 seconds. That means a navigation message is transmitted in 30 seconds. A navigation message is transmitted in a block of 30 seconds. In each 30 seconds, per second, how many bits transmitted? 50 bits. So in one frame, total how many bits you are seeing? How many bits will be transmitted in one frame, which is of 30 seconds?
1500.
Very good, 1500. So there are 1500 bits, which is basically 30 seconds. In 30 seconds, 1500 bits transmitted. Now these are divided in 5 parts, which are called subframes. So there is first subframe, second and third and fourth and so on. So we'll make that in a fresh manner. So this navigation message frame is divided into first subframe, then second, third, fourth, and fifth. 5 subframes are there. All this here and each one of them is subframe. मैं इसको शॉर्ट में लिखता हूं थोड़ा SFM करके, SF subframe. Since it is 30 seconds, so this will be of course 6 seconds, correct or not? Since they are equally divided. Since there were 50 bits transmitted per second, so there will be 300 bits or not? So each subframe is of 6 seconds, which is of 300 bits. This 300 bits are further subdivided in 10 parts. This 300 is divided in 10 parts, equal parts. That means there will be 30 bits, 30 bits, 30 bits, and so on. These each ones are called words. So there are 10 words in a subframe. Each word is how many bits? 300 bits. Think about it. Please structure what we have talked about so far. Navigation message, binary code, phase modulation, transmission rate 50 bps, transmitted in the form of frames of 30 seconds. This frame divided into 5 parts called first, second, third, fourth, and fifth subframes. Each subframe is of 6 seconds, which is equivalent to 300 bits. These 300 bits are further divided into 10 words. Each one is 30 bits, 30 bits, 30 bits. The first word is called TLM word, telemetry word. The second one is called how, handover word. For all the 5 subframes, the first one and second one is fixed. All of them are beginning with TLM, telemetry word, and followed by how, HOW, handover word. Now you might ask, what is this TLM? Telemetry words are, remote control commands basically for doing something, to take some action. Basically हमें एक remote control command भेजते हैं और वहां कुछ होता है. I am basically sending a telemetry command to them. Then how word is used for, transferring from one subframe to the other, and then also to transfer the CA code from transfer the command from CA code to P code. थोड़ा कॉम्प्लेक्स होगा समझना पूरी चीज को, बट इस चीज को हम लोग सिंपल में इतना मान करके चल लेते हैं. That it begins with TLM followed by how. Handover word is used to switch from CA code to P code by the defense services. Remember that P code is only used by the defense services. So this is mostly used by defense services receivers only. The remaining of them is having data. Remaining 8 words are data, that means 240 bits. 30 ये निकल गया, 30 ये निकल गया, तो 300 में 60 निकल गए, ओनली 240 रिमेन. So what data is there in the first, second, third, fourth and fifth subframe? Any question about this structure first of all, then we go to the data.
नो सर.
नो क्या नहीं समझ में आया कि कुछ पूछना नहीं है, सब समझ में आ गया?
नहीं, अभी तक 2 बता समझ में आ गया सर.
ओके, गुड गुड. तो अगर ये समझ में आ गया तो इसके आगे अब कुछ नहीं. So now we are talking about the data carried on each
Sir,
of subframe.
हाउ कमांड सिर्फ वो सीए से पीए कोड में स्विच करने के लिए है ना?
Yes.
ओके.
तो एक सैटेलाइट है, उसका सीए कोड होगा, पहले इससे रेंजिंग होगी, फिर वो पी कोड में जाएगा, फिर उससे रेंजिंग होगी, इन दोनों रेंज के बीच में डिफरेंस होगा, इंटरपोलेशन होगी और करेक्शन होगा, और करेक्शन होने के बाद सही रेंज निकलेगा सैटेलाइट से, और फिर वो ट्रायलैट्रेशन होगी. लोकेशन तो हमें पता चलेगा, अभी जो सब दूसरे सबफ्रेम्स में जाएंगे तो यहाँ लोकेशन का भी पता चल जाएगा, तो हमारा पोजीशन का एक्यूरेसी बढ़िया होता है. तो सैटेलाइट इज ट्रांसमिटिंग द सीए कोड, आल्सो ट्रांसमिटिंग पी कोड ऑन अदर फ्रीक्वेंसी, आई मीन द L1 itself. तो पहले इससे रेंजिंग होती है, फिर स्विच करते हैं, फिर इससे रेंजिंग होती है, दोनों के बीच का डिफरेंस आता है बिकॉज ऑफ सर्टेन बिहेवियर ऑफ डिफरेंट फ्रीक्वेंसीज. आपको पता है एमएफ का ट्रैवल पैटर्न दूसरा होता है, प्रोपोगेशन पैटर्न. पीएचएफ दूसरे तरीके से प्रोपोगेट करता है. अलग अलग फ्रीक्वेंसीज अलग अलग तरीके से करती हैं, तो एक फ्रीक्वेंसी पे ये सब काम होता है, फिर दूसरे फ्रीक्वेंसी पर कॉम्प्लेक्स मेथड है एक्चुअली. So how word is used to switch from CA code to P code? इतना लिख देंगे, बहुत 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 हो जाएगा. The first subframe is having satellite atomic clock correction signals. First subframe is having this. The second and third subframe, remember कि इसके पहले PLM और how होगा. The second and third subframe is containing ephemeris data, of each individual satellite. That means ephemeris is different for all satellites. What is ephemeris? This is precise orbital information of each individual satellite. Every satellite is transmitting this ephemeris data, which tells कि right now I am at this place and moving like this, at this height, at this speed, in this direction, etc., etc. So ephemeris is precise orbital information of each individual satellite. हर का ephemeris अलग होता है क्योंकि सब अलग अलग चल रहे हैं. The fourth subframe is used for alphanumeric data. Alphanumeric data, which is basically you can consider to be SMS service by the GPS. अगर मास्टर कंट्रोल स्टेशन आप जीपीएस रिसीवर और जीपीएस यूजर को एक मैसेज भेजना चाहती है, लेट अस से मेरी क्रिसमस, it is possible that they can use this fourth subframe to send you that Merry Christmas or Happy New Year, or trying to tell you GPS will not be working from so and so to so and so time because of technical glitch or problem. So fourth subframe is used for transmission of alphanumeric data to the user should the MCS wants to send that. If not, which is mostly the case, normally तो अभी तक तो हमने receive नहीं किया. If not, then it will be having almanac and health information of standby satellites. That means satellite number 25 to 32. क्योंकि 24 तो एक्टिव है, 25, 26, 27, 28, 29, 32, all 8 satellites are the standby satellites. So now we have 1, 2, 3 and 4 subframe. We understood first subframe, satellite atomic clock correction signals. Second and third, ephemeris data of each individual satellite. Fourth one, alphanumeric data. Should the GPS service wants to send a message to the GPS users, or in the absence of that, it is used for almanac and health information of the standby satellites. The fifth subframe is all about almanac and health info of active satellites. That means 1 to 24, or you can write satellite vehicle 1 to 24. So this is the structure of the navigation message. What we said, nav message in the form of frame of 30 seconds, at the rate of 50 bps, this frame is divided in all these subframes. Any questions? I think I completed this particular topic. What is navigation message transmitted by the satellites? Yes, sir.
Yes.
Understood?
Yes.
Okay. So now we will take a look at these three things: the data transmitted, the carrier frequencies and data transmitted, and a little bit more detail about this on the screen. On the slide, we will see all the three things. Just allow me to share the screen. Let me set it up. So we had seen the range calculation yesterday. We'll go behind sometime. All right, so take a look at this diagram. The satellite is transmitting, as we said, we are just revising that. two of the carrier frequencies, L1, L2. On L1, we have CA code, we have P code, we have got navigation message also. On L2, only P code and navigation message. P code on L2, navigation message on L2. CA code is only on L1. There are other frequencies also. Basically, ये ऐसे out of the box बात कर रहे हैं हम लोग. L3, L4, L5 are there, but they are used for different purposes. We are not concerned about them. So just in black and white, what we should write when we are to answer, write short notes on CA code. What is CA code? Just read through. I'm thinking honestly you are reading. Any confusion, please talk to me. Are we good here?
Yes, sir.
Next. Already? So this process, what is explained here, must now be quite clear to you, if you remember.
Yes.
Is it making a mental picture in your mind? ये क्या हो रहा है? कल डायग्राम
Yes.
देखे थे, कुछ बोर्ड पे कुछ एनिमेशन, वो सब घूम रहा है दिमाग में?
Yes, sir.
So this is about CA code. The P code now. Here it is 10 times faster rate, not 1.02, but 10.23 Mbps. The code length is extremely long, 267 days, not milliseconds, not seconds, not minutes. Next. So कल बात हुई थी, what is the use of allotting only a wiggly segment of the code to the satellite? Makes it more safe, because with each code there is a password kind of thing provided to the user. Using that code, they can use the P code. It is not open kind of affair. Anybody can receive it and make use of it. If you want to use it to get precise position, you need to have a password kind of thing. So that is P code. Now the navigation message. We have already discussed it, so I'm not reading now. I'm asking you to read and re-verify your understanding. और कुछ अगर ऊपर नीचे दिखता है तो प्लीज टेल मी. एक्चुअली ये फ्रेम्स तो हैं 30 सेकेंड्स के, लेकिन एक पूरा नेविगेशन मैसेज को डाउनलोड करने में there are 25 frames that should be downloaded. So actually 30 seconds one frame, 25 such frames is 12.5 minutes. 25 को डाउनलोड करने में 30 सेकंड 30 सेकंड 30 सेकंड्स के इतने सारे फ्रेम्स डाउनलोड करने में 25 of them. So for the GPS receiver, it takes longer time to get the first fix. When you switch on the GPS receiver, वो immediately आपको नहीं दे देता है position. Have you observed that? It takes little bit of time. Why it is taking that much of time? Because it is downloading navigation message, but before that almanac data. almanac data से पता करता है कि कौन कौन सैटेलाइट विजिबल है मुझको, उसमें से बेस्ट सैटेलाइट चूज करता है, उन सब के नेविगेशन मैसेज को डाउनलोड करता है, सबकी एफएमआरएस मिलती है, सबका लोकेशन पता होता है, फिर क्लॉक करेक्शंस होती हैं, फिर सारे के सीए कोड से सिंक्रोनाइजेशन होती है, फिर सबकी रेंजिंग होती है. एफएमआरएस डेटा मिल गया, रेंज मिल गया, अब कंप्यूटर का अपना काम है, वो बैठ करके ट्रायलैटरेशन के कैलकुलेशंस करता है और XYZ की वैल्यूज आपको दिखा देता है. दैट मीन्स लैटिट्यूड, लॉन्गिट्यूड एंड ऑल्टीट्यूड. ये लैट लॉन्ग जो है, व्हाट वी आर सीइंग ऑन द जीपीएस रिसीवर, has to have some kind of datum, chart datum से relate करना चाहिए. So GPS receiver by default is using WGS84. That means what position you are seeing on the GPS receiver, you can directly put onto the chart. एक क्वेश्चन दिमाग में आती है, आपके पास लोकल चार्ट है, आपने जीपीएस में पोजीशन देखा और उस लोकल चार्ट पे पोजीशन प्लॉट कर दिया. आपने सही किया या गलत?
गलत किया.
गलत किया. क्यों गलत किया?
सर डेटम चेक नहीं करा चार्ट में, कौन से चार्ट का डेटम है वो.
Exactly. So you can put the GPS position onto the chart अगर दोनों का डेटम एक ही है तो. If not, you have to apply a correction. What kind of correction? Datum shift. आगे बात करेंगे थोड़ा इसके बारे में. So navigation message here. Next. Navigation message is different for each satellite. By what component it is becoming different? Navigation message के contents में क्या different है सब satellites के लिए?
So ephemeris data.
Exactly. Very correct. Almanac सबका कॉमन होएगा, हर मैसेज में almanac is सेम, क्योंकि वो सारे सैटेलाइट कॉन्स्टलेशन 24 के बारे में बात होती है, तो सब लोग वही बता रहे हैं कि 24 कहाँ होंगे. बट ephemeris डेटा इज इंडिविजुअल टू ईच सैटेलाइट. वो सिर्फ अपना बता रहे हैं व्हाट हाउ एम आई मूविंग राइट नाउ. So is it now clear? Each subframe commences with telemetry word TLM. ये word क्या है?
Sir, this is the command, which is.
Yes, it is some kind of remote control command or the radio wave command basically. It is the first word. What is the meaning of this first word? ये word क्या चीज हो गई?
So word are these are divided. The words, there are 10 words. Each
Yes,
message,
exactly.
which is divided into, these 300 bits are divided into 30 bits.
Very good. Very good. So 300 bits divided into 10 parts, each part called a word, which is of 30 bits.
And the first word is TLM, second is
Always the how. Now what we were talking some time back, कि किस लिए यूज होता है ये? For acquiring
Yes,
P
sir.
code from CA code.
okay, sir. Go ahead.
Next. एक line about each of the subframes. Next, fourth subframe.
सर स्लाइड नहीं आई सर.
ओके, ये फर्स्ट सेकंड वाली नहीं आई स्लाइड.
No, sir. वही अभी
नहीं सर.
GPS नेविगेशन में 4.2 ही दिख रहा है.
हाँ 4.2 में. अच्छा नीचे जो, एक मिनट देखने दो. अभी क्या दिख रहा है? एक सेकंड. अभी क्या दिख रहा है?
आ गया. The first subframe contains.
Yes, okay, very good.
सर ephemeris डेटा में ऑर्बिटर इंफॉर्मेशन एंड स्पीड रहता है ना सर?
Yes, it's all about movement of the satellite. Orbit specification, their altitude, their speed, everything is there.
Okay.
And what is there in too much detail, I don't know, but in general this is what it is. अगर आप मुझको बोलोगे कि ephemeris डेटा बना के बताओ तो मुझको नहीं आता. But in general we understand that ephemeris data is having everything that can define the position of the satellite at given one instant. Understood?
Yes, sir.
Yes. और उसके आगे हमें जाने की जरूरत नहीं है, इतना हम समझ गए तो बहुत है. From the examination point of view, also it is okay. And for general purpose on board ship, what we do, ये जान भी लेंगे नहीं भी जानेंगे तो भी उतना फर्क नहीं पड़ता है ephemeris डेटा से. बट दूसरी चीजें जो एरर्स वगैरह हैं, that is more important for us because that is something that is practical. जो मैं पोजीशन देख रहा हूँ उसमें एरर है तो मुझको समझ में आना चाहिए कहाँ हो सकता है एरर, किस वजह से हो सकता है, क्या प्रिकॉशंस लेने हैं मुझको. नेक्स्ट, Slide 57. Are you hearing some background noise? अच्छा चलो खत्म हो गया. इसको रहने दीजिएगा. Don't break your head on this. So that is fourth subframe, either alphanumeric data, if not almanac of the standby satellites and health information of other satellites. Next, fifth subframe. Remember, we have been repeating the almanac is containing the data about all the 24 satellites. So we can identify which are the satellites visible to me right now, and I can choose the best satellites from all the visible ones. I think we discussed that if two objects are very close by, taking range and bearing from both of them will not be very good. They should be wider apart. So that's one criteria why two satellites may not be good even if they are transmitting good signal. I'm receiving good signal. So that's about it. Here is what we have discussed on board also. Take just 1 minute to discuss this. I mean, basically वही चीज है जो अभी हमने बोर्ड पे किया था.
सर ये स्पूफिंग का बताएंगे सर आप?
क्या चीज?
स्पूफिंग कैसे प्रिवेंट कर सकते हैं इसको?
नहीं, वो हमने कहा कि छोड़ देते हैं, उसके ऊपर में हम दिमाग ब्रेक नहीं करेंगे.
सर मैंने सर फेस करी भी है सर ये जीपीएस स्पूफिंग ना सर, तो उस समय परेशानी हो गई थी.
ओके, ठीक है. तो इसके बारे में थोड़ा और स्टडी करेंगे हम लोग अगली क्लास में. नाउ इट इज 11 o'clock ऑलरेडी व्हेन आई हैव टू लीव द क्लास. तो we'll take another opportunity to go through this. I mean, talk about this little bit. ठीक है?
Yes sir, yes sir.
All right. So basically we are now terminating the class. थोड़ा सा मेरे ख्याल से आप लोग पार्टिसिपेट करेंगे उसमें ऑनलाइन टेस्टिंग में. ठीक है?
Yes sir.
चलिए, okay then. Bye bye. Have a great day. Enjoy your time. Signing off now.
Thank you sir. Thank you sir. Thank you,
Okay, bye bye. Bye bye. So here is the satellite. किसी का माइक्रोफोन ऑन है ललित? Please mute your microphone. Thank you. So receiver is receiving here the signal. Here is time T1 पे ट्रांसमिट होता है, T1 पे यहाँ जनरेट होता है कोड. ये सिग्नल यहाँ पहुंचती है, पहुंचने में T2 हो जाता है. So T what we are saying is equal to T2 minus T1. But this T what we are getting is actually having an error which is T plus delta T. जो हमने ये T निकाला है इसमें there is an error which is the difference between the two times of the clocks. If this is, let us say, 1 second, so 1 second will translate into an error of the range. Why? Because we know now that range is equal to C into T, but here we have this as C into T plus delta T. That means we have the true range C into T plus C into delta T. This is the error. This is the true range. Then what kind of range have we calculated here? When there is error, this error is because of this, correct?
Yes, sir.
So the range that we have calculated, that includes the error due to time difference between the user and satellite clock, is called pseudo range. Pseudo range is equal to true range plus the error. True range is C into T, which was the actual difference, but the error is coming because of the time difference between the two clocks. So do we understand what is pseudo range? एक लाइन में define कीजिए what you have understood. Try to put them into word, your understanding into word, to define what is pseudo range. Yes, some volunteer please.
So the range calculated including the time error, which is between the user and the satellite, is called pseudo range.
Okay, very good. एकदम सही बात. The range calculated by the GPS receiver, which includes the error of the range due to time difference between user and satellite clock, is called pseudo range. The second part of the question, then how it is corrected? अगर हमारा सैटेलाइट यहाँ पे है, हमने पोजीशन सर्किल ये बनाया विथ अ रेंज R1 फॉर एग्जांपल. अगर R1 में डेल्टा का एरर है डेल्टा R, तो हमारा पोजीशन सर्किल तो ऐसा ना बनेगा भाई, और जो पॉइंट्स ऑफ इंटरसेक्शन होंगे वो गलत जगह पे बनेंगे, तो हमारा पोजीशन भी गलत आएगा. तो हाउ इज इट that we are still getting right kind of position? How the GPS receiver calculates position accurately despite the error in the range? So we have got pseudo range. We will represent it by PR, pseudo range, and 1 indicating that we are talking about satellite number 1. This we know is equal to C into T plus delta T. Or this is equal to C into T plus T into delta T. Now this error, one line answer to the second question, that this error in the range, pseudo range, is corrected mathematically by the GPS receiver. This correction is done mathematically by the receiver using the formula which is going to come next. So here we have pseudo range, here we have true range, and here we have error. So if we say true range of the first satellite is equal to, is it pseudo range 1 minus C into delta T? Is this correct or not?
Yes.
Pseudo range में से error निकाल दिया तो true range मिल गई. This is given by a formula x1 minus x whole square plus y1 minus y whole square plus z1 minus z whole square. That means basically true range is equal to this, where x1, y1, z1 is the coordinates of the satellite number 1. And x, y, and z are receiver coordinates. These are unknown figures. I don't know. The receiver does not know. But X1, Y1 and Z1 has been obtained from the ephemeris data. Navigation message. Location of the satellite is known. My position is unknown. So here we have got the true range using this formula. So similarly, we get true ranges of other satellites also, where we can say TR2 is equal to PR2 minus C into delta T is equal to under root X2 minus X whole square plus Y2 minus Y whole square plus Z2 minus Z whole square. And similarly, X3 and X4. Since we have three unknown quantities, X, Y, and Z, so we require four equations. That means we require four satellites, जिसमें चार सैटेलाइट का कोऑर्डिनेट्स होगा, चार सैटेलाइट्स के रेंजेस होंगे. Out of the four equations, we will be able to calculate the three variables, which is X, Y, and Z.
सर ये शिप के लिए तो सिर्फ एक्स और वाई चाहिए ना, जेड क्यों चाहिए होगा?
बेसिकली ठीक है, शिप के लिए सिर्फ एक्स एंड वाई चाहिए, बिकॉज शी इज नॉट गोइंग.
तो हमारे लिए तीन सैटेलाइट मोर देन इनफ होगा मतलब.
एक्चुअली यस, बट एक्चुअल लाइफ में आपके शिप में भी एक्स की वैल्यू है, सॉरी जेड की वैल्यू है. बोलिए क्यों?
वो हाइट की, इस हाइट पे एंटीना लगा है.
हाइट पे एंटेना लगा है तो सी लेवल से कितना ऊपर है? कहीं 42 मीटर होता है, कहीं 35 मीटर, कहीं 37 मीटर. ऑफ कोर्स आपके जीपीएस में वो डिस्प्ले भी नहीं करता होगा, जेड की वैल्यू डिस्प्ले भी नहीं करता होगा, बिकॉज जब जहाज के लिए बनी है तो यू डोंट केयर कि कितने हाइट पे लगा है, भाई जहाज कहाँ है. सो इट इज नॉट डिस्प्लेइंग, बट एक्स वाई जेड की वैल्यू लग सकती. योर अंडरस्टैंडिंग इज क्लियर कि हमें तो एक्स वाई चाहिए, जेड तो चाहिए नहीं. ऑल्टीट्यूड की जरूरत है नहीं, हम जहाज उड़ा तो नहीं रहे अपना, ना सबमरीन जैसा नीचे जा रहे हैं. सो एक्स वाई जेड में जेड की वैल्यू उतनी जरूरत नहीं है. सो वन लाइन आंसर टू दिस. फर्स्ट पार्ट हमने बात किया कि व्हाट इज सूडो रेंज. तो उसके लिए बेसिक कहानी बना करके कि हमें रेंज चाहिए होता है, सीए कोड से रेंज कैलकुलेट करते हैं, उसके लिए टाइम मैच करना होता है, लेकिन टाइम मैच नहीं करता क्योंकि लिमिटेशन होती है, समथिंग कॉल्ड क्लॉक बायस एरर. उसके चलते डिफरेंस ऑफ टाइम रह जाता है. एंड देन फाइनली वन लाइन definition of the pseudo range, that the range calculated by the receiver which includes the error in the range due to time difference between the two clocks is called pseudo range. The second part, that this error is eliminated or this range is corrected mathematically by the receiver in the following manner, where true range is equal to pseudo range minus error is equal to this. Since we have three unknown variables, we require four equations using four satellites. Thereby doing the trilateration, following the trilateration process, the value of x, y, and z can be calculated by the receiver accurately. Have we answered this question?
Yes, sir.
सर अगर एग्जैक्टली मैच कर जाएगा सैटेलाइट से, तो मतलब कोई सूडो एरर कोई सूडो रेंज नहीं होगी, मतलब ट्रू रेंज इज इक्वल टू सूडो रेंज।
सूडो रेंज तो सूडो रेंज ही है, एरर तो था, हमने एलिमिनेट कर लिया ना।
नहीं, इन केस अगर मतलब एज्यूमिंग कि अगर एग्जैक्टली मैच करता है एटॉमिक क्लॉक से, तो मतलब
हाँ।
कोई एरर।
एग्जैक्टली अगर 0.00000 मतलब 0.00000000001 सेकंड का अगर मैचिंग हो गया तो एरर नहीं हो। अगर होगी तो 1 mm की होगी या आधे mm की होगी या 1/10 mm की होगी। अगर 001 रह तो गया है ना। अगर कोई एरर नहीं है, दोनों क्लॉक एक ही साथ चल रहे हैं, तो नो एरर।
ओके सर, अंडरस्टूड।
But there will be error due to other factors. There will be errors because of other factors. Not हमने टाइम डिफरेंस वाला तो देख लिया, उसको सूडो रेंज बोल भी दिया। But you can understand this कि अर्थ है हमारा यहाँ पे, रिसीवर है यहाँ पे somewhere, the satellite is here, the signal is coming. Is it coming direct or it is getting refracted in the atmosphere?
वो रिफ्रैक्ट तो होएगा सर वो।
तो लंबा चल के आएगा ना, देर से आएगा। मेरे पास जो टी निकली है उसमें तो ये वाला पाथ है, सीधा वाला पाथ तो है नहीं। सो दिस आल्सो विल बी हैविंग एन एरर। तो अल्टीमेटली द रिसीवर विल हैव अ रॉन्ग रेंज, और उसके चलते यहाँ पे फिजिकल पोजीशन है हमारी, तो बताएगा यहाँ पे थोड़ा सा दूर बताएगा। सो सूडो रेंज को तो हमने ठीक कर लिया।
वो आएगी जी, मतलब वो एग्जैक्ट कभी आएगा नहीं, आएगा सूडो ही।
हाँ, एक तो सूडो आएगा क्योंकि यहाँ टाइम में फर्क है ना भाई, टी और यहाँ पे टी प्लस डेल्टा टी है ना। एक तो ये है सूडो रेंज।
अगर टाइम सेम भी है तो भी बाकी फैक्टर्स की वजह से जो फर्क पड़ेगा उसको भी सूडो रेंज ही टर्म देंगे हम
ना। उसको सूडो रेंज नहीं देंगे, उसको नहीं सूडो रेंज सिर्फ टाइम डिफरेंस के चलते।
ओके सर।
बाकी जो एरर्स है वो सिंपली रेंज एरर्स है। बाकी जितने सारे हैं दे आर रेंज एरर्स बिकॉज ऑफ दिस, बिकॉज ऑफ दैट, बिकॉज ऑफ दैट। बट द रेंज एरर बिकॉज ऑफ टाइम इज कॉल्ड
सूडो रेंज।
एग्जैक्ट। तो सिर्फ टाइम वाले फैक्टर को, क्योंकि वो प्रोसेस का पार्ट है और उसमें अपडेट नहीं हो पाता, तो जो हम निकालते हैं वो सूडो रेंज ही निकलती है हमारी, क्योंकि दोनों क्लॉक्स बराबर नहीं है। अब उसके अलावा एक्सटर्नल फैक्टर्स हैं बहुत सारे, जिसके चलते हमारा रेंज फिर और गड़बड़ होता है। तो वो जो रेंज गड़बड़ होता है उसको वी आर एट्रीब्यूटिंग टू सर्टेन फैक्टर्स। बिकॉज ऑफ दिस देयर इज रेंज एरर, बिकॉज ऑफ दिस देयर इज रेंज एरर, बिकॉज ऑफ दिस there is range error, and so the problem will be there in the GPS fix. Okay, are we good?
Yes sir.
Position fixing हो गई? So
yes,
if the question is asked, how does the GPS receiver obtains position fix? Question is, how does the GPS receiver is obtaining position fix? तो इसमें सारी कहानी शॉर्ट में करके लिखनी होगी, शुरू से लेके अंत तक। What? There are satellites in the sky. They are transmitting L1, L2 frequencies. On that, they have got pseudo random codes and nav message. The receiver obtains the location of the satellite from the navigation message, and using the pseudo random codes, namely the CA code, calculates the range of the satellite by the formula C into T is equal to range. For calculating the range, आपको दोनों एक साथ कोड जनरेट करता है, वो वाली प्रोसेस देनी होगी कि रेंज कैलकुलेट हो गया। Then लास्ट में एक लाइन, using trilateration method, these are resolved into equations using 4 equations. the receiver is able to calculate the three variables X, Y, and Z. ठीक है? Okay? Any questions?
No, sir.
सर ये जो टाइम वाला एरर है ये लगा के वो सूडो रेंज कैलकुलेट किया, बट वो जैसे रिफ्रैक्शन हो या कोई और फैक्टर से तो वो मतलब दैट यू सेड रेंज एरर्स, तो वो कैसे कैलकुलेट करेगा वो? दैट इज नॉट इन द सूडो रेंज.
गुड पॉइंट. डीजीपीएस सुना है आपने?
जी सर.
डीजीपीएस
जी
वैसे करते हैं. ठीक, आगे आएगा अभी.
ओके सर.
Yes. हम लोग उन एरर की जो प्रॉब्लम थी उसको सॉल्व करने की कोशिश करेंगे बाय सम अल्टरनेट मेथड. So we'll try to do this correction by means of something called DGPS and something called WAS, WAAS, Wide Area Augmentation System. That will be the last topic of the GPS. I have got a GPS receiver. Here it says somewhere, when I'm looking through this, it says WGS84. And here is the chart where I want to put. यहाँ पे lat long है मेरे पास. I want to put this on my chart. And on the chart, I see here written PZ90. जो ये position है, can I put it here?
No, sir.
You are very right. You are very right. But of course, I want to. It is my job to explain. But can you explain why not?
Because the position, the GPS calculator is based on WGS84, which is the chart datum for that position, which is the imaginary sphere on which the GPS actually plots the position. And the charts which we are using is based on some other geodetic datum,
Very good.
chart datum which we cannot use. We have to apply this longitude and latitude corrections.
Very good.
Before it.
Ditto, 100%. Bingo. 100 points for you. This is Russian datum. Russian charts ka datum is PZ90. While this one is UKHO. So the GPS is going to show lat long in WGS84. This is the default datum which is normally used by the GPS. But you can navigate through the software of the GPS and you can display this other datum also. The lat long here can be displayed in other datums also. So now this is PZ90, the lat long PZ90, the chart is also PZ90, and so you can plot this position directly onto the chart. So this requires little bit of understanding of these chart datums. What is this WGS? What is this PZ90? So slight bit of illumination on that. The Earth is a spheroid. यहाँ का रेडियस और यहाँ के रेडियस में फर्क है. ये कम है और ये ज्यादा है इक्वेटर पे. In order to map the world has been divided into imaginary lines running from pole to pole and a line, imaginary line, which is cutting through the center in two halves. The lower part, of course, is called south, the upper part is called north, and these are further divided into parallels of latitude. So this is an Earth which is too big. If I want to name this particular line, I have to start from somewhere. A measurement cannot be done until and unless I have a zero reference. So to count this longitudes, I have to start somewhere. So a reference line is taken to be 0, 0. And counting the number of lines, we come here at longitude so and so. Then we are at this place, so we must also count how many of parallels of latitude to reach this point. So we have calculated the longitude here, starting from this meridian, which we call the Greenwich meridian, and from equator we count the latitude. So this is the model of the Earth. To represent a point, we are representing this by means of a number called latitude and longitude. Longitude measured from somewhere, it is measured from somewhere. This mapping, who will do? कौन करेगा ये? In the world, who will be doing it?
UKHO.
Why not? Why can't I do it? Who is UKHO? मुझको किसी ने रोक रखा है क्या? मुझको किसी ने रोका कि मैं चांद को देखूं ऐसे? मैं अपने घर में बैठा हुआ अर्थ का मॉडल बनाऊंगा, आपको तकलीफ है क्या? So what I mean to say, there are many countries who have their own model of the earth, and accordingly they take different reference points. UKHO आपने सही कहा. Why? Because this is the worldwide accepted norm, most popular datum, almost everybody using it. It has got wide coverage. Almost the whole world has been covered by their survey. So everybody is using UKHO. The charts, UKHO. Even the GPS system, which is US based, has adopted their methods of charting WGS84 as default. But have you seen the masters when they go in a difficult situation, difficult ports, then they ask the local charts. Please provide me the local chart. Have you seen that experience?
Yes, sir.
Yes, sir.
Yes, sir.
So why is he asking the local chart when he already has the WGS84 chart, which is worldwide accepted? Then why he is insisting on local chart? To understand that, right now I am standing at a place.
Local data may be more accurate and recent.
Okay, yes, more accurate. But why? More
Because
accurate, why?
most of the UKHO surveys were done very early, like 30-40 years back, and most of the countries are doing surveys now, so their data will be more accurate, as well as the technology is evolving. So maybe with the latest technology they are doing.
One thing is right, 30-40 years and aaj ka survey. But if they are using Greenwich as a reference point and equator as a reference point to count lat long, if I want to know my position right now where I'm standing, start the counting from Greenwich meridian and come to my position, counting the latitudes 102, 103 east. How many miles counting? Number one. Compare that number or accuracy of that number starting from Greenwich, and if I measure this from लाल किला, अगर लाल किले से मैं रेफरेंस लूं मेरे पोजीशन का, तो मेरा पोजीशन लाल किले के रेफरेंस में सही होगा कि ग्रीनविच के रेफरेंस में ज्यादा सही होने की उम्मीद है?
लाल किला सर.
Naturally, because it is the local chart, local datum, local reference points. Maybe I'm not counting the Greenwich meridian as my 00. Mostly equator तो सबके लिए बराबर होगा. but my reference points are different. So there are geodetic systems around the world which have got different models of the earth having different reference points. And that is what we call the geodetic system. Like we have already seen in the example, Russian datum PZ90, Papa Zulu 90. Then there is WGS 84, World Geodetic System. तो ये 84 क्या आ गया?
Year 84.
Yes. The thing is, these are constant improvements. पहले जो हमने अर्थ को देखा और जो लैटिट्यूड लॉन्गिट्यूड में डिवाइड किया, we observed some errors. तो मॉडिफाई किया, इंप्रूव किया. ओके, ये मॉडल नहीं, ये वाला मॉडल सही हो. और देखा, उसमें भी एरर निकली और इंप्रूव किया. So 1960 it was made, 1970 it was made, amended in 1972, then further amended in 1984. The last amendment, the last mapping of the world was done in 1984, and that is the mapping which is very close to being accurate. And so there are different versions of this mapping, and that is known as WGS 60, WGS 70, WGS 72. The last which is in use is the WGS 84. So right now here, if I find my position in latitude longitude in WGS 84, it will be something, some latitude, some longitude. If I take the local chart and local datum for the same position, there will be different latitude longitude. Same physical point, same place where I am standing has got different latitudes, longitudes in different datums, in different types of mapping of the world. So what will happen if I use the same latitude, longitude and put on two different charts of different datums? क्या होगा? Same latitude, longitude on this chart, same on the other datum chart. तो क्या होगा?
So error.
What kind of error?
Wrong position because the reference points are different.
थोड़ा जोर से बोलिए, थोड़ा सुनाई नहीं पड़ रहा.
Sir, positions will be wrong because the reference points are different.
That means when we plot this, दो physical अलग-अलग point में दिखाएगा.
Yes, sir.
एक यहाँ पे दिखाएगा तो एक यहाँ पे. दोनों के बीच का difference जो है, physical difference between the 2 points represented by same latitude longitude on two different datum is called datum shift. Same latitude longitude WGS 84 पे डाला तो यहाँ बताता है, PZ 90 पे डाला तो यहाँ बताता है. दोनों के बीच का difference is called datum shift. Are we good?
Yes, sir. Understood.
So WGS 84, the datum shift. Simple question जो हमने सबसे पहले पूछा था, if the GPS is showing one datum, the chart is another datum, can we directly put the position on the chart? No, we cannot. We can put the GPS position on the chart only if the two datums are matching, the GPS and the chart datum. If they are matching, yes, we can put, which we have been doing. आज तक तुम जहाज में यही करते थे, GPS देखा, यहाँ पे position डाल दिया, no issues. Why? Because that is default WGS 84. The chart that you are using is also WGS 84, so no issues. But cannot do it on the local chart. If local chart, तो उसमें datum shift का आपको apply करना होगा error. To put the position correctly, या तो GPS में datum change कर दीजिए chart के हिसाब से, या अगर उस position को plot करने को देख रहे हैं, then you have to apply the datum shift error. ठीक है?
Yes, sir.
So we are done. Next class में we will go little quickly. वैसे मेरे से क्विकली होता नहीं, पूरे डिटेल में बात ही निकल जाती है मेरे से. So 3 topics are remaining. One is speed determination, the other one is error, and the third one is something called DGPS. So these are the 3 topics. The satellite is moving in the sky in the orbit. Right now probably it is here. इसका XYZ is known to the receiver. इसका XYZ is known. Because the GPS has taken the pics, knows the position. So the declination of the satellite can be calculated by the receiver that it is so and so. At this particular moment, the GPS is moving in this direction at the speed of V, something like 3.9 kilometers per second. So V is known, and this angle is also known. So because of this V of the satellite can be resolved into 2 components. One component is towards the receiver, the other component perpendicular to it. So if this is 1, this is perpendicular to 1, which is second component. Since we have V, we have alpha, so V cos alpha, the relative motion can be calculated. So there is a relative motion between satellite and the receiver. Meanwhile, the satellite is transmitting signal on L1, which is 1575.42 megahertz. Because there is a relative motion, the receiver receives something else, 1575.52, for example. Why? Because the receiver and satellite are coming close to each other. After this point, it will be going away. After overhead, it will be going away from the satellite. So right now there is an increase. If it was only because of V, the frequency shift should have been, for example, let us say 50. Because of this relative motion, the actual frequency shift should have been so and so. But what the receiver is observing FR is more, 1575.52, for example. 0.02 megahertz is extra. So how is this extra coming? It must be coming because there is more relative motion. क्योंकि ये तो जो चल रहा है सो चल ही रहा है, इसमें तो कोई चेंज नहीं हो. The reason for more frequency shift can only be for one reason, that the receiver is also moving towards the satellite, thereby increasing the relative motion. More relative motion, more frequency shift. So इन्हीं सब को रिजॉल्व करके वो एक वेक्टर निकालता है रिसीवर के मोशन पर. So receiver is moving towards or away from the satellite. If it was going, let us say 47, that means the receiver is going away from the satellite. So the change in actual motion, relative motion, the change in this can only be added because of the motion of the receiver. So इन दोनों को resolve करके a vector is taken out for the motion of the receiver. Now this can be in any direction. This motion is further resolved into 3 coordinates. 3 coordinates, that means 3 components, x, y, z components. So एक निकल गया, एक के साथ 3 कंपोनेंट निकल गए, but this may not be true. One satellite does not give the clear-cut understanding of the receiver motion. Why? Because if I go towards you, yes, I am going towards you. But if I go here, then also I come close to you. If I go there, then also I come close to you. So for this 180 degrees, I am going close to you, and this 180 degrees, I am going away from. So not with one satellite, but 3 satellites, these vectors are calculated. All these 3 speed vectors are resolved into XYZ, और उन तीनों के XYZ के combination से एक final vector निकलता है, which is the movement of the receiver. That vector can be either on x-axis or y-axis or xy-axis or xyz-axis, x, y, and z. If there is a helicopter on which the receiver is placed, then it is lifting up. So course made good and the speed made good, both can be calculated, and it is calculated, and it is displayed onto the screen of the receiver. So in simple terms, what we are talking about, once again, if we talk about the same thing, that receiver is knowing the position of the satellite, it is knowing its own position, having taken the position fix. The relative motion can be calculated because we know the movement of the satellite from the ephemeris data. So we know the location, we know the orbit, we know the speed, etc. So with this, relative motion can be calculated. This relative vector can be differing only if there is further motion added by the receiver. So उस receiver का speed vector is calculated and resolved into XYZ coordinates. Similarly, with other 2 satellites, more of such vectors and more of such XYZ coordinates are calculated. And resolving the 3 of them together, a final vector is calculated for the receiver, which is the actual motion of the receiver. 3 vectors that we say, if the receiver is going like this, there is one vector, one coordinate, one component, other component. But if it is also going in this direction, let us say away from the wall, going in this direction, so there is another component here, which is this component. So X, Y, and Z component. 3 components. The receiver is moving in this direction. So simply, this is the method of calculation of speed. This is resolved from the Doppler shift effect. It observes how much of change of frequency on the basis of that this, and this, if it is not matching with only the motion of the satellite, then it is only because of addition of speed by the receiver, either addition or subtraction. कुछ पल्ले पड़ा?
Yes, sir.
पक्की बात?
Yes.
All right. So this is how the speed and course is calculated. I hear that nowadays they have satellite log also, satellite speed log. The method is same, but they have dedicated only for calculating the speed. So satellite log also, if it is true, there was somebody saying in the second mate class to me that there is satellite log in the ship, like Doppler log, EM log, satellite log also.
अभी तक तो मैंने नहीं सुना सर सैटेलाइट लॉग.
नहीं सुना है?
नहीं सर, मतलब मैंने 2017 बिल्ड शिप पे सेल किया, तो वहां पे तो ऐसा कुछ नहीं था सर।
हो सकता है सेकंड मेट में, मैंने वही कहा, आई ऑल्सो डोंट नो, बट सेकंड मेट में सम स्टूडेंट वाज सेइंग कि सैटेलाइट लॉग ऐसा ही होता है क्या सर, ऐसे ही काम पे होता है? तो ही वाज आस्किंग मी, तो if you are coming across such log which is satellite log, so you can understand what is the method used by that satellite log also. The other method, just one liner, which you don't have to write an answer about, don't have to mention that in the MMD exam, but you might know. The position of the receiver was here, XYZ. Now it is here, XYZ. So at T1 it was here, T2 it was here. So the time taken is T, and the distance covered between this time T is so and so. So speed can be calculated. That will be distance by time. Simple. This kind of method is used in poor kind of GPS receivers, which are not so versatile, not so advanced kind of devices. So right now, at which place you are getting your speed? ये speed कहाँ का मिल रहा है? यहाँ का, यहाँ का, यहाँ का, कहाँ का मिल रहा है? Let us say at A and B and C. So A या B या C कहाँ का speed मिल रहा है आपको?
पूरा AB का है सर, एवरेज।
But right now you are getting at this point now, this calculation has been done for T2. So T1,
yes sir,
T1, यहाँ का speed मिल रहा है ना?
yes sir,
So this was historic. ये पीछे जो गुजर चुका है वहां का स्पीड बता रहा है. It is based on the history of the
Yes.
movement.
yes,
So it is not so correct. But Doppler shift effect, right now at this place, what is happening? How much of frequency shift is happening? On the basis of that, it is giving for this position, not historic, but right now. Anyway, historic it is, but that will be in nanoseconds or something. Everything that we see and observe is history. है या नहीं? मैं आपके सामने खड़ा हूं, आपसे बात कर रहा हूं, जो मैंने कहा, जो बोल रहा हूं, वो हिस्ट्री है या प्रेजेंट है?
हिस्ट्री।
हिस्ट्री है. व्हाई?
जो बोल दिया आप वो तो हिस्ट्री हो गई है सर.
एग्जैक्टली जो मैंने बोल दिया वो यहाँ से वहां गई, वहां से प्रोसेस होके आपके कान तक पहुंची, हिस्ट्री हो गई. ARPA में is also happening like this. ARPA is also giving you what was happening. वो भी ARPA में भी जो आप कैलकुलेट करते हैं अपना प्लॉटिंग, उस प्लॉटिंग में क्या है, तो आप O लेते हैं, A लेते हैं, उसके बीच में डिफरेंस निकालते हैं, तो वो पास्ट का है, उसके बेसिस पे, पुराने डेटा के बेसिस पे कैलकुलेट करके स्पीड बता रहा है. So actually what you are looking in the, even on the radar, is basically history. Of course it is very short history, which may be considered, which we do consider as present. ठीक है? Any questions
Yes.
on this?
No sir.
Next one is errors of the GPS. Now we have known that for the receiver, two inputs are required in order to calculate the position, in order to take the fix. Two inputs are required: position of the satellite and the range. Based on these two inputs, the receiver will calculate your X, Y, and Z. If any of the input goes wrong, then this will definitely go wrong. Input wrong, output definitely wrong. So what are the reasons that this position may go wrong or this range may go wrong? Or if there are some other factors which may also cause error in the position picks. So we are basically trying to look at these two inputs, why they are going wrong. What are the factors that can cause error in the inputs, which will result in the error in the output given by the receiver. So in a very, very simple plain language, first one is satellite clock error. Number two, user clock error. Do I need to explain these two? Do I need to explain these two? Satellite clock error. The satellite is having atomic clock. This atomic clock is not matching with the UTC time. So there can be difference between UTC time and the satellite clock time. Difference existing between this and this. Then the user clock error, which is the difference between satellite and user clock. So यहाँ से यहाँ का error, this is not giving the right time, then further on the user clock. As we know, the range is given by C into T. So any element of error in the time is going to cause error in the range, and this range in turn will give you wrong XYZ. So these two are the causes of a range error. The third one is called propagation delay, which we have already discussed in the previous class. The Earth is here, receiver somewhere here, the satellite is transmitting signals. The signal, when passing through the atmosphere, is getting refracted because of different layers of the atmosphere. The layer D, E, F, etc., etc., F1, F2. This also changes during night time. अगर GMDSS का याद हो, F layer becomes F1, F2. D layer is closest. So troposphere, ionosphere, etc. All those are having different kind of densities, and because of that, there is refraction. What is refraction? Amitoj sir, what is refraction?
The change in direction of light when goes from one medium to another.
Very good, very good. Remember that these factors are dynamic. During daytime, there will be some kind of behavior. The same place during nighttime, it will different because two layers will merge together. F layer will become, F1, F2 in the daytime will merge into one. Ionization will be less, so refraction properties will change. If you are in summer at the same place, the refraction will be different. In winter, they'll be different. In other rainy season, it will be different. So what happens actually, that the actual range from here to here is this straight line, but this is, since it is going and taking a longer path, the time taken is again in error. So this time taken here into C gives you a wrong range. Wrong range, wrong position picks. So third one is propagation error. Fourth, something called multipath error. The satellite is transmitting signals, receiver is here somewhere, and near the receiver there is a building also. So the signal travels to the receiver, but the signals also hit this and it is getting reflected back. So the receiver is receiving two signals, or maybe more than two signals. One coming direct, one getting reflected from some other obstructions, reflecting surfaces. And so the receiver is inducing two kinds of current, two kinds of input signals, which is confusing for the receiver. So not going into details of this, this also causes error in the range. So this is the 4. Next one is something called GDOP. This requires little bit of understanding. So what is GDOP? G stands for geometric dilution of precision, DOP. Dilution of precision. What we are diluting? What we are diluting? What are we diluting? Precision. So what does the common sense say? When dilution is more, what will happen to precision? What should happen to the precision? Common sense.
Precision should reduce, or precision should reduce.
Exactly. So if dilution goes high, precision goes down. If dilution goes less, or if dilution goes less, precision goes high. That means, are we talking about the accuracy? यहाँ पे है तो इधर बताएगा या इधर बताएगा, इधर यहाँ पे बता रहा है, मतलब डाइल्यूशन इज मोर, तो दूर हो गया. Is that what? Accuracy of the position is getting affected, correct?
Yes, sir.
Then one question that comes to my mind, then why we are calling precision, why not accuracy? TOA क्यों नहीं बोला हम? That means there is something to do with precision and accuracy. To understand the difference between the two, let us take 4 cases. The point of intersection here is the actual position of the receiver. Case 1, 2, 3, 4. The GPS gives you the position, latitude, longitude, which says that it is here. Whatever the value, but the DOP value, GDOP value, tells you that it is high. That means DOP is high. That means precision is less. So the GPS is telling you कि यहाँ पे है, lat long तो ये है, but there is a possibility that I can be anywhere in this area. So position ये बताया, but not sure of the precision कि यहीं पे है या नहीं. Second case, that the GPS is saying that you are here. Remember that you are actually here. but DOP is low. That means precision is high. It says that you are here, you are no longer, no more than this much from the pointed position. Then there is third case when you are here and the DOP is like this, something tells you this. And the fourth case when you are here and DOP says something like this. So now can you see the cases of accuracy and precision in the four cases? Case 1, case 2, case 3, and case 4. Is it precise? Is it accurate first of all? Are you getting accurate position?
No, sir.
Not accurate. Is it precise?
No.
No. No accuracy, no precision. What is the condition here?
It's not accurate but precise.
Yes, not accurate but precise. This, what does it say?
It's accurate but not precise.
So now you are aware, and fourth condition, both accurate and precise.
Yes.
So this error has come in the position because of range errors and so many things. Because of the range errors जो हमने clock error बोला, propagation error बोला, ये सब उसके चलते ये error आई है. But DOP is a different matter. That is not talking about accuracy, but it is talking about precision की जो बताया है वो कितना plus minus होने की उम्मीद. So we say here when it is not precise, DOP is high. And here DOP is less. So this DOP is actually just a number, it is a ratio. In a very, very crude manner, if we say, DOP is the ratio of actual position to the calculated position. Actual position to the calculated position. So अगर दोनों एक ही होगा, ratio of actual position to the calculated position, दोनों अगर एक ही होगा, जैसा यहाँ पे है, then what is the DOP? If both the values are same, the ratio of the two values will be what?
1.
1. So DOP1 is the ideal value. If the DOP is 1, then it is ideal value, the best precision that you can get. But the number will increase and the precision will be increasing, decreasing rather. जैसे जैसे नंबर बढ़ेगा इसका सर्किल बढ़ेगा. क्यों होता है ऐसे? Why does it happen? This has to do with the geometry of the satellites in the sky. If the receiver is here somewhere, there are two satellites close by. If they are making a circle on the Earth, both will be making similar kind of circle or not? Position circle will be very close.
Yes.
But if they are wider apart in the sky, so इसका सर्किल कुछ ऐसे, इसका सर्किल कुछ ऐसे बनेगा या नहीं?
Yes.
So if we take it a view from the top, these position circles. So one of the satellite is making a position circle like this. Part of the circle, I'm not drawing the full. And there are two lines that I have drawn. Why? because there will be range error. प्लस माइनस तो हो ही सकता है, यहाँ हो सकता है, यहाँ हो सकता है. ये रेंज का एरर है, ये शॉर्ट रेंज का सर्किल है, ये प्लस एडेड रेंज का है जो प्लस माइनस हो सकता है. If the two satellites are close in the sky, their circles are close to each other, and in doing so, the other circle that will be like this. So the point of intersection is what? Is this the point of intersection?
Yes.
But if the two circles were apart from each other, will that be something like this?
Yes.
So do you see the point of intersection? Now,
Yes, sir.
can we relate it to this situation? And can we relate it to this situation?
Yes, sir.
This is what is the DOP all about. It has to do with the geometry of the satellites in the sky. Wider satellites give better DOP. That means less DOP. Resolution is less, better precision. If they are close in the sky, then they give poor DOP. That means more DOP. Precision is less. DOP more, precision is less. Why? Because the satellites are close in the sky. And that is why the GPS receiver, when downloads the almanac, we have been saying that after downloading the almanac, GPS receiver को पता चल जाता है कौन कौन सैटेलाइट कहां कहां पे हैं, and then it chooses the best satellites for position fix. Now, do you think when you switch on the receiver and it downloads the almanac, will it choose two satellites which are close in the sky? Should it?
No, sir.
Exactly. So this may not be used. This may be used, this may be used, but this close by in the sky, not used, because it is going to give poor DOP. Are we good?
Yes, sir.
All right. He said GDOP. Geometric dilution of precision, which is a general name for this kind of situation, but there can be different types of DOP. Something called HDOP, PDOP or BDOP, PDOP, something called TDOP. These are different type of DOPs. This for horizontal. H for horizontal DOP. This for vertical DOP. This for position DOP. This one for time DOP. This horizontal DOP deals with 2D position. That means latitude and longitude only. Vertical deals with altitude, precision of the altitude that you are measuring. This one deals with 3D position. That means combination of these two. This deals with time, of course. Precision of the time calculated. Now the values of this HDOP and PDOP, जहाज में इसकी तो जरूरत है नहीं. So the values of HDOP or PDOP may be available, not maybe, it is available, and most likely displayed onto the main screen also. What is the HDOP value right now on the screen? You can see. If not seen, maybe you can navigate through the software of the GPS and find out that value. If the HDOP of equal to or less than 4, it is good for sea navigation. A value equal to or less than 4 is good HDOP, allowed for safe navigation. PDOP equal to or less than 6, remember it is just a number, it is just a ratio. PDOP equal to or less than 6 is allowed for navigation. If the values go more than this, there will be an alarm sounded. The GPS receiver will start giving alarm that it is not able to give you right kind of accuracy or precision. So are we good with GDOP?
Yes, sir. Understood.
You will find these values in the IMO performance standard for shipborne GPS navigation navigator also. These values are from the IMO performance standard. Next one is orbital error or ephemeris error. We know that the receiver is receiving from the satellite nav message. In nav message there is ephemeris data, almanac. Almanac से तो कोई ज्यादा मारा मारी नहीं है, जनरल लोकेशन पता चलता है. But ephemeris is providing exact movement of the satellite to calculate exact location of the satellite by the receiver. So how is it possible that it is always giving correct information to the receiver? ये सही है, कैसे मॉनिटर होगा ये? The MCS, Master Control Station, through the ground antennas are uploading ephemeris data every 2 hours. The MCS is getting the information of the satellite from the monitor station. Information where it is right now is getting the information from monitor station. It calculates predicts the path. If it finds out, then ephemeris data is amended and it uploaded every 2 hours, so that the ephemeris data transmitted by the satellite is correct for the receiver. The receiver can calculate right position. But between these 2 hours, it is possible for the receiver to deviate from the predicted path. अभी अगर यहाँ पे रिसीवर ले रहा हो और बताएगा वो तो यहाँ कि हम यहाँ चल रहे हैं, क्योंकि एफएमआरएस डेटा ये कहता था कि ये पाथ है, but actually it is moving on some other path. So there is an error between the place it is saying that I am and where it is actually. Because of this, the range again will be an error, and if the range is an error, the position fix is going to be in error. So we can call it orbital error or ephemeris error just from the reference point of view कि हम कहां से कहां से बोल रहे हैं. अगर यहां के बाद देखें तो ऑर्बिटल एरर है, अगर यहां से देखें तो एफेमेरिस का एरर है. यहां पे रहते हुए बोल रहा है कि मैं यहां पे हूं, यहां पे रहते हुए बोल रहा है यहां पे हूं, तो ऑर्बिट गलत बता रहा है. So orbital error or ephemeris data both can be interchanged. मैं आपसे बात कर रहा हूं या आप मेरे से बात कर रहे हो, it's like that. So these are some errors of the GPS system. We will take a look at these errors on the slides. The basic ones we have already talked about. One question is generally asked, what are the various errors and how much of error is caused because of these factors? How much of error? If it is propagation error, how much error? If it is multipath, how much of error in the range? If it is user clock and this clock and that clock. So we will take a look at a table where there are few values given against each kind of errors. So sharing the screen. Next. Already spoken, so I will not speak much. Just go through the slide. Next, 92. The application of dual frequency receiver using L1 and L2, these errors are minimized. एक फ्रीक्वेंसी पे रिसीव करेंगे तो कुछ एरर आएगा, दूसरे फ्रीक्वेंसी पे रिसीव करेंगे तो कुछ दूसरा एरर आएगा. Why is that? Because two different frequencies travel at different speeds or the propagation behavior of different frequencies are different. Like we already know, VHF travels in a different manner, MF different manner, HF different manner. So यहाँ पे high and low frequencies L1, L2 also travel differently. So उनका error का difference निकालते हैं, उसे interpolate करके और they try to maximize the accuracy of the range. But this facility is available for only the defense services. Normally, civilians will use only one receiver, single frequency receiver, and hence not that kind of precise positioning that we get. We get SPS. Some added information. Another point of selection of right kind of satellites. I might be receiving signal from a satellite, but it is too close to the horizon. Not going to use it. Too much of refraction, too much of error in the range. Next, 94. Next. Are we good with this?
Yes, sir.
जो फॉर्मूला देखा था सेम वे 3 or 4 satellites, 3 for our 2D position, 4 for 3D position. Atomic clock use atoms like cesium, rubidium, और इनके वाइब्रेशंस को वो मेजर करता रहता है, उनके वाइब्रेशंस पे चलता है. Updates are happening with each vibration of the atom, which is very very precise, as we said, to the tune of 9 billion vibrations per second. So there is a master clock here, and clocks are updated by sending signals also. They should match with the ground atomic clocks, which is maintaining the UTC. Next, '98. Next, 99. As you can see, the intersection area of the circles are quite large, because all the position circles are overlapping with each other very closely. So this is the case where GDOP is going to increase 3, 4, 5, 6 ऐसा बढ़ने लगेगा, and accuracy or precision will reduce. Next, next slide. I think you can relate to it now. Next, satellites are close in the sky. Next, 105. (106) multipath error. (107). So the antenna should be placed away from such reflecting surfaces, not in the shadow of the funnel and things like that. It should be away so that the whole sky is clearly visible to the antenna. Multipath error depicted in diagram. Next. Next. अच्छा ये पिछले ही वाले इसमें था. This got repeated. So the ground antennas are constantly updating the ephemeris, but यहाँ पे between two updates there can be possibility that there is a minor drift in the orbit, results in range error. So here is this table of the errors caused by different kind of errors. As we have seen, SV clock is basically satellite vehicle clock. SV ephemeris is ephemeris error. Selective availability है तो सही आपके इसमें, लेकिन वो GPS ने बंद कर दिया है बहुत दिनों से. Selective availability is no longer being practiced. This was to intentionally reduce the accuracy of the position fix. The master control station will upload wrong data to the satellite. Wrong data means what? Basically the error in time. They will introduce intentional error in the time signal uploaded to the satellite. Then what I receive, उसमें भी एरर आ जाती है, तो रेंज गड़बड़ हो जाती है मेरी, और उसके चलते पोजीशन भी गड़बड़ हो जाता है. So this they wanted to have a control over the usage of GPS fix. So they introduced this selective availability. But Bill Clinton के समय में, I think in 2000, the resolution was passed by the US Senate and then they removed it. Selective availability is not being implemented in the GPS system. So no longer existing. आयनोस्फेयर का देख रहे हैं, एटमॉस्फेरिक डिले, सूडो रेंज नॉइस, रिसीवर नॉइस भी होता है, हमने पढ़ा नहीं अलग से, बट रिसीवर का भी नॉइस होता है. दैट मे आल्सो इंट्रोड्यूस सम बिट ऑफ एरर. So are we good with this?
Yes, sir.
Yes, sir.
Okay, good. Few minutes to differential GPS. We'll go on the board for this purpose again. Differential GPS is basically an augmented GPS system. Augmentation course का नाम सुना होगा आपने, फायर फाइटिंग का augmentation course, तो मेडिकेयर का augmentation course. वहां पे क्या होता है? Definitely we know that some material is added in your knowledge. थोड़ा सा कुछ एक्स्ट्रा बताते हैं आपको क्लास में, so you have a better understanding of the subject. Similarly, here also it is the same thing. There is this GPS system and then there is something called augmented GPS. Augmented GPS. That means GPS को थोड़ा सा सपोर्ट कर दिया. क्या सपोर्ट कर दिया भाई? The position accuracy is more relevant in the coastal area because of presence of so many of hazards, shallow patches, wrecks, buoys, etc., etc. So position accuracy requirement in the coastal area is more. So if your ship is here, you need to know what is the exact position, because just next to you may be buoys and things like that, maybe a wreckage or something here. But this is receiving signal and we have already seen that there can be plus minus, थोड़ा इधर थोड़ा इधर थोड़ा इधर, position बताएगा. So how to increase the accuracy of the position? This is done by augmented GPS, as we said, AGPS. These are two types, something called DGPS and something called WAAS. DGPS is differential GPS. This is wide area augmented system. This is land-based system. This is satellite-based system for long range, for short range. So what happens in this case? Here on the shore, there is a normal GPS antenna installed, a normal GPS. The ship is at sea. In the DGPS system, since it is located on land, so there is a known position. Because it is on land, so no ambiguity. Latitude and longitude is known. known position. But the GPS here is receiving signal from the satellites and also giving a GPS position. So there is a known position lat long, मालूम है मुझको मेरा position, लेकिन GPS भी बता रहा है and that is also giving me lat long. Naturally, there will be difference between the two latitudes and longitudes. So what do I have if I compare these two? Do we have error?
Yes.
And this error is transmitted by the DGPS reference station. This is now DGPS reference station. इनके पास एक अलग एंटेना होता है और ये MF पे फ्रीक्वेंसीज ट्रांसमिट करते हैं. MF फ्रीक्वेंसीज पे these errors are transmitted. The coordinates errors, latitude longitude का error is calculated by the GPS reference station, DGPS reference station, and it is transmitted on MF frequencies to the other ships in the vicinity. Now your ship was here, you are already calculating position, you already have a GPS lat long. ये आपके जहाज ने कैलकुलेट किया है, जीपीएस ने, और आपका डीजीपीएस जो है वो ये फ्रीक्वेंसी रिसीव करके ये एरर भी रिसीव कर रहा है. सो प्लस माइनस एरर एंड करेक्टेड lat long is available to you. Simple understanding is this. So
Yes.
हाँ बताइए.
No, it's understood.
Okay. So DGPS is doing this. What we are correcting here in the first case that we have seen, it is coordinate correction. But this error of the position was for this position or not? जो ये error निकाली गई थी वो यहाँ के लिए error था ना? जो error निकली थी वो इस position के लिए error थी. तो यहाँ पे जहाज है तो चल जाएगा, थोड़ा और दूर गया तो भी चल जाएगा, लेकिन जहाज अगर दूर गया तो इस एरर की वैलिडिटी रहेगी क्या जो जहाज दूर जा रहा है?
No, sir.
So for short range, this DGPS is working fine. 50, 60, 70, 80 miles तक चल जाता है काम. But for long range, when the ship is going away, there is another method which is used, and it is called pseudo range correction. What happens in pseudo range correction? Second method. Again, the DGPS reference station. GPS का पोजीशन यहाँ पे इसका अपना मालूम है, known position, that means latitude, longitude and altitude, everything is known because it is on the land. It is receiving signals from the satellites. What it is doing, इसका अपना पोजीशन पता है, 3-dimensional पोजीशन. एफएमआरएस डेटा से इनका पोजीशन पता चल गया, जो एफएमआरएस डेटा ट्रांसमिट कर रहे हैं. उसके बाद सीए कोड वगैरह यूज करके इसका सूडो रेंज सबके सूडो रेंज भी कैलकुलेट कर लिए गए. There is an error in the range which we are calling as pseudo range. So now there are all the visible satellites, जितने 5, 6, 8, 9, 10 जितने satellites को ये देख रहा है, सबके pseudo range को obtain करता है वो. or now that there are two fixed points in space, एक यहाँ पे और एक यहाँ पे, तो इनका रेंज कैलकुलेट हो सकता है कि नहीं मैथमेटिकली? अगर दो कोऑर्डिनेट्स हों आपके पास चार्ट में, तो आप दोनों के बीच का डिस्टेंस निकाल सकते हैं या नहीं?
Yes, sir.
So here will be, come again? कुछ कहा आपने? All right. So there is a pseudo range which includes error, but there is calculated range mathematically because of two known points in the space. So इन दोनों को अगर कंपेयर करें तो रेंज एरर मिल जाएगा कि नहीं हमें?
Yes.
So these range errors are calculated for each of the satellites, and these range errors are again transmitted to other ships. Now what the ship is doing, during the process of its own position fix, it might be using this satellite, and some other satellites which is not visible to it. तो जो सैटेलाइट्स के सिग्नल को ये यूज कर रहा है, उसके सूडो रेंज इसने भी निकाला, सूडो रेंज इसने भी निकाला, और उसमें वो एरर ऐड कर दिया, एरर अप्लाई कर दिया. So now what the GPS receiver here is having is a corrected range. इसका तो सूडो रेंज निकला था, बट उस सूडो रेंज को करेक्शन अप्लाई करके now almost correct range it is getting, not 100% but very close. And after getting this range, then is the trilateration, then is the position fix, and it is displayed onto the screen. So first case में last point पे जाके correction apply होता था, pseudo range में पहले correction apply होता है, फिर calculation वगैरह होके तब lat long दिखाते हैं. So these are the two methods of augmented GPS system. We call it by the name of DGPS, but it is basically an AGPS system, augmented GPS system. Remember that this will not be available, this service will not be available when you are going out of the service area of this medium frequencies. So एक logical question आता है, can a normal GPS be used as a DGPS receiver? Yes, sir. Can DGPS receiver be used as a normal DGPS, and normal GPS can be used as a DGPS receiver, or there is any difference? आयुष, जल्दी जल्दी बोलो भाई, टाइम हो गया. आयुष.
I don't think.
Yes, मोहित, जोर से बोलिए, जोर से, माइक्रोफोन नजदीक.
No, sir. A normal GPS cannot be